All right, we're recording live in the future past from the Oregon coast. So fun with roots. So roots are essentially the opposite of powers. So kind of what we call an inverse. So some examples of roots, if we know, for example, that 3 to the second power is equal to 9, then there's a related expression, the square root of 9 has to be equal to 3. So what does the square root of 9 mean? It means what number would you square to get 9? So if I go starting the other direction and start off with, say, the square root of 25, then the answer is going to be whatever number I can square to get 25. And sometimes we can look at these numbers and say, oh yeah, right, I remember 5 times 5 is 25. So then we can say the square root of 25 is 5 because we know that if we take 5 and square it, we get 25. Now, there were a couple of homework questions related to how negative numbers fit into all this. So let's come over to the side here. If I wrote what number squared is equal to 25. Now you might say, hey, that right there looks the same as this right here, but it's not. In this case right here, I started first with the square root and then I thought about squaring. Here, I'm starting with the square and ending up with a number. And it turns out if you start with a square, so start with the square, then it turns out there's two possible options here. Either I could take 5 and square it to get 25, or parentheses -5 squared also equals 25. And there was a prep question related to this. Keep in mind, caution here, the square of -5 is written like that, as opposed to the opposite of 5 squared, which some people would read as -5 squared. Those things are not equal. And the reason is the definition of the negative symbol, what that really means is multiply by -1. So anytime a computer sees something like the opposite of 5 squared, the computer's really thinking, oh, that's -1 times 5 squared. And if you think about the order of operations, you're supposed to square first. So this says, okay, take 25 and then take the opposite of 25, which is -25, okay? So that's what I get with this notation right here. If I use the notation where I have parentheses -5, I'm squaring the parentheses. So that means take the parentheses and multiply it by itself. There happens to be a -5 inside the parentheses. Negative times a negative is a positive. 5 times 5 is 25. Okay, so you can see that the square of -5 is not the same as -5 squared. And if we ask a calculator about that, so let's try Google. And if I type negative and then 5 and then raise that to the second power, it's going to follow the order of operations I just mentioned. So that's different from saying parentheses, take the opposite of 5, and then square the parentheses. And that gives me positive 25, right? So that's important. So here we go. So back here, this is a super important idea on the top right, that if we start with a missing square equals some number, there are two possible answers. So one of the answers is 5, the other answer is -5. So the next question is, how does this problem relate back to this problem over here? So next, oops, wrong button. That's the button, there we go. So the relationship is in an idea called the principal square root of a number. So every number has two square roots, the principal square root and the other root. So the principal square root is non-negative. Okay. And I say non-negative because you can't take the square root of 0. It is 0. So I guess almost every number has two square roots. 0 only has itself. And the other root is the opposite of that. So negative. And the principal square root is this symbol right there. Okay. Now I put a little mark at the end there so I can tell what's inside the root and what's not, because sometimes I'm a little messy. So some people might write it without that little hook at the end and just like that as their square root symbol. But the square root symbol is technically the principal square root symbol. And so this symbol, again, means the non-negative root. So if I start with that symbol, for example, like I did earlier, say the square root of 25, the only answer to this is just 5. If I said, what's the square root of 9? The only answer is 3. If I want the other root, not the principal one, then the only way to make that happen is just to put a negative in front of the root. So the other root of 25 would be written negative square root of 25, which means first take the square root and then apply the negative. So that'd be negative 5. What's the other square root of 9? That would be written as the opposite of the principal square root of 9. And that would be the opposite of 3 or negative 3, right? So one root is just the symbol itself around the number. The other root is a negative sign in front. So if we just start with a square root, there's only a single answer. Even if there's a negative up front, there's still just a single answer. The tricky part comes when I start with a square. And so if I start with x squared is equal to, let's try 144. This is going to lead to two possible answers because when you square a number, you lose the sign. So either x could be 12, and I got 12 by just remembering that if I take 12 times 12, it is 144. Sometimes I don't remember those and I have to ask a calculator. So to ask a calculator, I would say, all right, I don't remember how 144 factors. Calculator, please just tell me what's the square root of 144. So that's one answer. The other answer would be the opposite of 12, negative 12, which on a calculator would just be to type a negative sign and then the square root and then the number in question. All right, so let's just double check in the calculator. Make sure my math's okay today. So if I say, hey, what's the square root? And this calculator starts with a parentheses instead of drawing a line across the top. And then I type the number. Oops, too many 4s. And then I close the parentheses on this particular calculator. Again, you have to master your own calculator. I get 12. Desmos does not use the parentheses. So if I go to Desmos, it draws the bar over the top trying to tell me what's inside and what's not inside. And the bar just kind of grows with your number there. All right, so it says the square root of 144 is 12. And the other one is negative 12, the other root. Spreadsheets can do square roots also. And so you can type a square root. So another notation you might see for a computer that's not a simple calculator, we would say SQRT and then parentheses and then whatever number I want. And so a lot of times I'm working in a spreadsheet and I need a square root. And so that's how I would type it on a spreadsheet, equals SQRT 144. And it doesn't matter whether you capitalize the SQRT. All right, so one of the prep assignments was, can you list perfect squares, like the square of 1, the square of 2, the square of 3? Because it's nice if we can recognize those. If we don't recognize them, it's not a huge deal. We can still kind of work it out. So let's take a look. There's my mouse. At some non-perfect squares. Suppose I started with a problem that said y squared equals 11. In order to break this up, what I would do is, again, it's going to break into two problems because I'm starting with a square. And one of them is y equals the square root of 11. The other one would be y equals the opposite of that square root of 11. And I know that 3 squared is 9 and 4 squared is 16. So 11 is not a perfect square. So the only thing I can do at this point is go to a calculator and say, hey, calculator, what's the square root of 11? So new line, square root 11. And my calculator says it's 3 points. Let me write this down so I can get it right in my notes. 3.3166247.9. And different calculators will give different numbers of decimals. Yeah, I got that. So let's write it down. So we get the principal square root, and I'm going to use the wavy equals, which means I'm rounding. And the calculator rounded this to 3.3166247.9. And you may decide, like the homework problem said, hey, give me less decimals, like 5 or 2 or 3. So there's versions of that. And then the other one is just the opposite of that. So y is approximately negative 3.3166247.9. And again, we'll usually be told where to round. And often, for a problem like this, I think I'd probably round to 3 decimal places. So 2, 3 decimals. We could say that y is equal to 3.317. Oftentimes with a problem like this, you'll see notation like y equals plus minus the square root of 11. And what that really means is what I wrote down here. It means put an or in between. So if this were like a homework problem I was trying to answer and there's a box I need to type in for that, I would say one answer is the square root of 11, comma for the or, and then the other one is the opposite of the square root of 11. And again, if you're not sure if something's a perfect square, whip out your calculator and your calculator will totally tell you. All right, let's try something a bit more challenging. 2 more problems that are a bit more challenging, and then we're gonna jump into the lesson together. But first, where's my Zoom screen? Down here. Does anybody have any questions? Let's check the chat. Chat is quiet at the moment. All right, let's see. Somebody give me a thumbs up that you're still alive and well out there. Okay, thank you very much. All right, let's get moving then. So, moving my Zoom stuff out of the way. Some places we might see square roots besides these kind of weird generic problems. In area problems, a square is often involved. Area, volume problems, we get a square sometimes. So a couple of examples of these: the area of a circle is pi times the radius squared. Volume of a cylinder, like a can of soup or something, volume, not area. Try that again, that's better, is pi times r squared times h. And just a reminder about what each of these means. So here's my attempt to draw a circle, and there is a center for that circle, and the distance from the center to any point on the edge is what we call the radius. So if we measure that distance or someone gives it to us, we can calculate the area by squaring the radius and multiplying by pi. For a cylinder has a circular top and then these straight sides that come down. Let's try that again. Not too bad, not too bad. And then the bottom, uh-oh, my internet connection is unstable. Let's hope I make it through class here. So the height is just the distance from the top to the bottom, and like that circle over there, the radius is the distance from the center to the edge. And that's a funny looking R. There we go. So let's suppose we're playing with a circle and we knew the area. Let's say the area was 300 centimeters squared. And we wanted to find out what radius goes with an area of 300 centimeters squared. Well, we would just set the two equal. So pi times the radius squared equals 300. And at that point, I'm not going to worry about the units. But pi is multiplied here. So to solve this equation, I would divide by pi. Now, pi is about 3, but not quite. So if I divided by 3, I'd get about 100. But that's a little bit off. Pi is not exactly 3. Although in some state, I think it was Minnesota, they tried to pass a law to make pi equal to 3 because they thought 3.14 was too complicated. That was crazy. Anyway, so pi divided by pi is 1, so that leaves just r squared is equal to that 300 over pi. And then the next step would be to take the square root. And technically, when you take the square root of a square, it's a plus or a minus, like I was talking about before. And then we just have the square root of that whole fraction. And I think it's best to not use the calculator right away here to get it down to the square root and then use the calculator. So we only round once at the end. Otherwise, you're going to round multiple times and introduce error. So let's see if we can agree on what that answer is. Plug it into the calculator and then type the answer into the chat. So I'm going to whip out my calculator. And I'll try it on both the Desmos calculator and the Google one. So I want to know what's the square root of 300. And once you get that, plug it into the chat, see if we agree, over pi. And the trick there is to make sure the pi ends up inside that square root. So in Google, I just need to make sure my parentheses are in the right spot. 300 divided by pi, close the parentheses, and both calculators say it's about 9.77. So hopefully somebody help me out in the chat here. Awesome, you guys rock. Yeah, good, 9.772 to 3 decimal places. Nice. So again, we got to practice using our calculators. In this particular section, we're going to use calculator for every single problem pretty much, unless we just look and see, oh yeah, I remember the square root of 9 is 3. But that doesn't happen too often. Thank you for participating. All right, so that's one example where we have to kind of solve an equation like that. Another one might come up, will come up for sure, where remember the braking distance problem we did last week? And so that problem for braking a car, stopping a car, is the distance in feet was equal to the speed of the car in feet per second divided by some calculation we had to do. And let's suppose we had the number 46.37. So if somebody told us how fast or what the distance was, we could figure out what the speed was. So maybe they'd say, hey, the distance is 120 feet. Can you tell me what the velocity was? Another question I might ask is, suppose the distance was twice as long. So suppose d was equal to 240 feet. Remember, we played with that last week. What would the velocity be? So I'm going to set up the first one. Solving the second one is pretty similar. I would just take this equation, this expression v squared over 46.37, set it equal to 120 and solve. So to solve this, I need to get rid of the division. And so we would do that by multiplying by 46.37. And again, we could whip out our calculator on that, or we just leave it like that for now. Multiplying usually works out pretty nice. Dividing is usually kind of messy. So the point here is this divides out, leaving just the v squared. And that's equal to whatever 120 times 46.37, and I'll worry about that in a minute. But at this point here, since the square is all by itself, I can do what's called take the square root of both sides, kind of like we took the log of both sides before. And whenever we do that, starting with a square, we've got to remember that the answer could be positive or negative. So there's a plus or a minus going on. So there's two possible answers. However, in this case, we're talking about speed. And usually when we're talking about the speed of a car, we state it as a positive number. So I really don't need the negative here. I can ditch it because it's a speed. Okay. So we only need positive because it's speed. So sometimes you can reason you don't need one of the answers. You only need, oops, positive, since this is a speed of a car. All right, so then it's calculator time, and we ask our calculator, what is that? So square root of 120 times 46.37, close parentheses. I get about 74.595. So this is about 74.595. And if we think back to this lesson last week, the distance was measured in feet and the velocity was measured in feet per second. So this number right here would be feet per second. And I probably want it in miles per hour. So I'd have to go back to my calculator and say, what is this in miles per hour? And if you forgot how to do that, just a reminder to take like something like, what was that again? 74.595. And I'm going to rewrite it as feet over seconds, feet per second. To change it to miles per hour, I need to get rid of feet, so it would have to go in the opposite place. So that would change to miles. And then I would also want to get rid of seconds. So since seconds is in the bottom, I put it in the top, and I can go from seconds to hours. And I remember there's 5,280 feet. So 5,280 goes with the feet in 1 mile, and there are 3,600 seconds in an hour. And the point of this is it tells me whether I multiply or divide by each number. Oops, crossed out the wrong one, to get my miles per hour. So I would multiply by 3,600, divide by 5,280. So let's do that on our calculator right there. So times 3,600. And sometimes I forget whether I should multiply or divide, which is why I set up that fraction. That tells me. Okay, so that would be more like 50.86 or 51 miles per hour. So this is approximately 50 point, oh, that's a crazy looking 5.86 miles per hour. The only difference between this first version of the problem I wrote and the second one is the first one I had 120 inside the root. Next time I do it, I'll have 240, and I want to compare the distances. And so this is the beginning of one part of the lesson. All right, one more problem, and then we'll get going on the lesson together. Another place square roots come in to play is in geometry. And in geometry, it's the Pythagorean theorem, which refers to right triangles. So with the Pythagorean theorem, you have to have a right triangle. So starting with a right triangle. And if you forgot what a right triangle was, a right triangle, the right means you have a 90-degree angle. Often called a square angle. So for example, maybe I have that side there, and then this side comes off that way, and here is my 90-degree angle. Usually we make a little square to indicate which one's the 90-degree angle. And the orientation could be anything. So the triangle could be set up like this right here. And then I believe that looks pretty close to a right angle to the best of my artistic ability. So the right angle could be on any corner. It's just the corner that has that square angle there. And when you have a right triangle, regardless of the orientation, the sides attached to the right angle, those are called legs. So there's a leg here and there's a leg there. So on this triangle down here, the legs are this one and that one. And then the side across from the right angle is always called the hypotenuse. Hypotenuse. Down here, hypotenuse. And it's the longest side because the 90-degree angle is the biggest angle in a right triangle. Any triangle only has 180 degrees for the 3 interior angles. And so if this one's taking up 90, the other two have to share 90. So the right angle is always the biggest angle in a right triangle. The legs are usually given the letters A and B, and it doesn't matter which is which. So over here, maybe that's A and that's B. It's not necessarily that A is the bigger one or the smaller one. It's just one leg is called A and the other leg is called B. And the hypotenuse is usually given the letter C for its length, okay? So A and B are the lengths of the legs. And C is the length of the long side, the hypotenuse. So the legs have to be measured. Oops, got an extra letter there. Actually, it's just singular, isn't it? There's only one hypotenuse. And what the hypotenuse, there we go. And what the Pythagorean theorem says is that if you take the legs, A and B, and you square them, and then you add them up, you'll always get the same as the long side squared, okay? So this says the sum of the squares of the legs equals the square of the long side. Always the way it works. So for any triangle, that's a right triangle. If this doesn't work, it's not a right triangle. If it does work, it is a right triangle. So being a right triangle and having the legs meet this equation right here are the same idea. You can't have a right triangle that doesn't meet this equation, and if a triangle does meet this equation, it has to be a right triangle. So a couple famous right triangles. Oops, famous does not have an E, usually. Right triangles. The most famous is a triangle that has one leg is a 3, the other leg is a 4, and as long as that's a right angle there with the 3 and the 4, then the distance between the endpoints there, that diagonal, that hypotenuse, is always going to be 5. So I'll use this in construction a lot when I'm trying to make sure my wall is straight up from the floor, or that 2 walls meet at a right angle. I'll measure 3 feet out one way, 4 feet out the other way. I'll make a mark in each spot, and then I'll double check that it's 5 in between. So if we just double check that, what is 3 squared plus 4 squared? That would be 9 plus 16. 9 and 16 is 25. And Pythagorean theorem says that the 3 squared plus the 4 squared better match the 5 squared. And we know 5 squared is 25, right? So that's a pretty famous one. Another famous right triangle is if you have a length of 1 on one side and a length of 1 for the other leg, then what's the distance in between? So we'll calculate this one right here. What is that hypotenuse? So the Pythagorean theorem says take 1 squared, add it to the other 1 squared, because those are the 2 legs, and that's equal to the other side. So we'll call the other side C, because that's what it usually is. And it's got to be squared. 1 squared is 1, plus another 1 gives me 2. So now I get 2 equals C squared. To figure out what C is here, I would take the square root of both sides. Now technically, when we take the square root of a square, we're supposed to have a plus or minus. So the answer should be C is plus or minus square root of 2. Now 2 is not a perfect square, so I need a calculator. There are 2 possible answers. One of them is the square root of 2, or the other one is the negative square root of 2. But these are lengths here. And usually when I'm talking about lengths aren't not negative. So non-negative. So I would just say, nah, I don't really need that one right there. I'm just going to stick with the positive square root of 2. So let's whip out a calculator, find out the square root of 2. Square root of 2, my calculator says it's 1.414-ish. So it's approximately 1.414. So what that tells me is if I have a right triangle and the legs are the same length, then the hypotenuse is going to be about 41% bigger longer than either of the legs. Okay, so those are a couple of famous Pythagorean theorem results. All right, let's get into the lesson, and then after that we'll jump into the homework. So I'm going to unshare for a sec. See who's here. All right, so we've got Abby's here, Caleb, Kylene, Ari, Zach, Larissa, Jacob, Alejandra, Jesus, welcome, Jesus, and hey, Tia. All right, if those of you have cameras, could you just wave, let me know you're live and out there and well. Yeah, good to see you, Jesus. Hey, Zach, good to see you there. All right, Larissa, what's up? Tia. Uh-oh, Tia's got a mask. She must be around other people. Good luck, be safe. Okay, let us jump into some groups now.